So in this problem, we want to find the area of the region bounded by the graphs of y equals 3, y equals the fourth root of x, and y equals 0. I wouldn't know exactly how to set up the integral without really seeing it visually, which I've had enough math experience I can do in my head, but you guys may need to graph this thing out in order to see it so that you can figure out how to set up your integral. Okay, so x equals 0 is this vertical line right here. That's the easy one. Well, y equals 3 is also easy to graph. Okay, so that's this line. Fourth root of x, though, that one you may or may not remember. The graph of the square root of x kind of takes this shape like this. And the fourth root of x does the same thing, it's just a little bit steeper and slower, so it kind of does that number. It's not precise, but that's the right idea. Okay, so they're going to intersect somewhere. Oops, there's fourth root of x. They're going to intersect somewhere out here. And the question is, where is that point of intersection where y equals 3, the equation of that line, intersects y equals the fourth root of x? We need to figure out what is that x so that we can set up our integral to find the area bounded by those three functions. Okay, so in order to find that x, we need to solve for where do these two functions equal each other, where do they have the same y value. So we're going to set 3 equal to the fourth root of x to solve for where they intersect. So to solve this equation, we're going to raise both sides to the fourth powers. So we'll have 3 to the fourth equals x. 3 squared is 9, so 9 squared is 81. So these intersect at x equals 81. So that means that this area is equal to, let's see, the integral from, we're looking at the x values here for the limits of integration. So the first x value is right here at x equals 0. We're going to integrate all the way out to x equals 81 is my upper limit of integration. Now we're finding the area between two functions, so we do the greater function minus the lower function, or the top minus the bottom. So the top function between 0 and 81 is y equals 3, minus the lower function, right here, is the fourth root of x. Okay, so from here it's just purely computational. So the antiderivative of 3 is 3x. For the antiderivative of the fourth root of x, remember fourth root of x is x to the 1/4. Okay, so when we add 1 to that exponent, 1/4 plus 1 is 5/4. So it's 1 over 5/4 x to the 5/4 from 0 to 81. Before I plug in and subtract, I'm going to simplify. 1 over 5/4 is 4/5, which flips the denominator. That's supposed to be a 4, not a 9 there. And that's going to be from 0 to 81. So we're going to plug in 81 minus plug in 0. So 3 times 81 minus 4/5 times 81 to the 5/4 minus what we get if we plug in 0 here is just 0. I always like to write it just so that I get in the habit of it. Okay, so from here, let's do a little bit on the calculator. So let's do 3 times 81 is 243. So I have 243 minus, okay, do a little bit in my head here. 81 to the 5/4, let's work on that. Okay, that means the fourth, it's looking like a 9, but fourth root of 81 all to the 5th. Fourth root of 81 is 3. The reason we got 81 in the first place was by, over here, by cubing or raising 3 to the fourth power. So the fourth root of 81 is 3, so it's 3 to the 5th. So let's see what 3 to the power of 5 is. It's also 243. So that is 243. So over here I have minus 4/5 times 81 to the 5/4. So it's minus 4/5 times 243. So let's get a common denominator, which would be probably 5 here. So we're going to multiply 243 times 5 to get 1215. So So I have 1215 over 5 minus 243 times 4 is 972. So I have 1215 minus 972 is 243 over 5. Is that exact area?